So what I'm going to talk through here, I'm just going to try and give you kind of a little bit of context about, I suppose, the Burren coastline and about the sort of the biodiversity in that we find there, but just to sort of put it in a bit of a global context first, just so we kind of know what we're looking at. And then basically I'm going to go through a slideshow of pretty pictures with you. I'm going to go through just touch on some of the different species we find along. All right.
Okay, sounds great.
Okay, so I'll get this up and we'll share it. Okay. So let me know if you can see it.
Yeah, it's starting to share. Yeah, I can see
Okay.
your hand. Yeah.
All right. So for the start, I suppose with anything to do with the Burren, you're getting back into the geology. And as my background was kind of fishing and marine science, to end up in an area where the geology was almost exclusively marine was a pretty handy in for me. So while I'd done a bit of geology at college, really the fact that I was looking at organisms, fossilized organisms that I could recognize was quite handy. So here, what you're looking at in this first picture is just a fossilized communal coral. So this is part of the evidence that kind of proves to us that the Burren was a tropical sea back when this limestone was formed. So you're talking about 320 to 360 million years ago. And so that's why we'll recognize the marine organisms at that time. Very little of what we know of or what's familiar to us as kind of living things had evolved at that stage. So you didn't have any mammals, you had no dinosaurs, you didn't have trees, you had no flowering plants. So we had sharks, which were fully formed, and we were just starting to get winged insects. All right, so things were very different. But as we go around, let me see if I can flick along here. Oop. Okay, so just see if I can. Okay. So this then is a solitary coral, and you've also got some crinoids sticking out. Again, these are marine.
Sorry,
creatures.
Cormac, sorry to interrupt you. It hasn't moved. Actually, it's still on the first slide.
Okay, so you're not.
I'm not seeing the second slide.
Okay, see if I can do it slide by slide here.
Maybe you might need to stop sharing and start again and see if that works.
Okay. See if this goes.
Yeah, I see the next one. Yeah.
I'm just wondering if I can move through them now.
Yeah.
Yeah. So that's flicked
Yeah,
across.
it's moving. Yeah.
Okay.
That's great. Yeah.
So these are solitary rugose corals. Again, just evidence of the shallow tropical sea that we had 360 odd million years ago. So while this is not in the Burren, this is Burren adjacent, okay? So this is in the shales that you'll find capping, well, in the Burren still, capping some areas of the Burren, like around Lister and Varna, and that make up the Cliffs of Moher, okay? So some of these slides I'll have, while the actual photographs may have been taken beside the Burren, almost all of the creatures that you'll see in this, you'll find along the Burren shore, all right? So just to give, again, this is how the rock got here. It was by these creatures basically accumulating calcium carbonate in the hard parts of their bodies, so in their skeletons or in their shells. And then as they die, these parts drift to the bottom of the seafloor and accumulate. So when you're looking at the Burren, you're looking at an accumulation of dead animal parts. So it's an awful lot of dead animal. Makes it a bit different from most other types of rock. Now, this is where we try and put our own kind of biodiversity in context, in a global context. So for the kind of immediate story, and I say immediate in a loose term, we're talking geology here, but in the more recent kind of events that have framed our biodiversity and have caused our biodiversity to be what it is, you've got to go back to about 2.5 million years ago. So they believe that the ice age cycle that we're in now was triggered 2.5 million years ago. And the reason it was triggered was prior to that time, you had a channel running between the Pacific Ocean and the Atlantic, about the area around where Panama is. So the fact that these two oceans were joined meant that they regulated each other's temperature, and that would have created a kind of a climactic stability within the Atlantic. At that time, the islands, like Ireland, like the Azores, any of these islands that exist in the Atlantic, and specifically in the North Atlantic, would have been more similar to Pacific islands when it comes to biodiversity. So when we think of biodiversity, when we think of the Pacific Islands, we think of places like Hawaii and Fiji, where every single island has a large level of endemism. So it has creatures that have evolved solely on those islands and that are specific to those islands. So when you go to Hawaii, there's a vast range of animals that you will only find on those particular islands, like the Galapagos as well. You'll find even from island to island within a chain, you've got a huge variety of endemic species. We would have had similar levels of that endemism prior to the closing off of that channel. So what's happened is when the channel between North America and South America clicked together around Panama, this cut the Atlantic off from the Pacific. And being a much smaller ocean, it has a tendency to heat up in a way the Pacific doesn't. So you end up with water heating up around the Gulf areas, and that kicked off the Gulf Stream current, which then cuts across the Atlantic and flows up past our coast. What that does is it delivers moisture-laden air from these tropical areas to Ireland, as most of us will have noticed this summer. So the rain that we get, the mist that we get here on the West Coast is a direct result of this current drawing this moisture-laden air up and then dropping it along our coast. Now, if you get a bit further north with this current, it drops this moisture as snow. And as this accumulates over years, this is what kicks off our ice ages. So once this cycle began, and by cycle I mean ice ages tend to last, in the recent cycle we've been in, ice ages tend to last for around 100,000 years. Then you enter into a glacial period like the one we're in now. On average, they last for about 15,000 years, and then you're back into an ice age again, okay? What this cycle did was, this meant the end for a lot of endemic species. If you're on an island in the Atlantic and you're not able to adapt to an oncoming ice age, or you can't move and get somewhere else, you're not going to make it. So we would have had, like one example, we now have one species of puffin in the Atlantic. It's likely we had 5 or 6 at one stage. And this shift into this ice age cycle just meant that most of them didn't make it. So when you travel around the North Atlantic islands today, unlike the Pacific, where you have varieties of different birds on each island, you'll tend to see the same 7 or 8 species of bird on almost all of the North Pacific islands. So we'll see kittiwakes, we'll see puffins, we'll see guillemots. So we see these birds that are able to survive big climatic changes. They're able to move, but we don't see large levels of endemic species. So this is for land-based animals. So Ireland, when it comes to our land-based animals, our biodiversity is not huge. It's not bigger than mainland Europe. It's less than the UK, because at the end of the last ice age, they still had a connection to mainland Europe, which meant some creatures were able to get back up. But because we're an island, we basically get scraped clean to an extent and then have to refill. Birds can make it back, but it's much more difficult for other animals. So if you were to have a line of latitude, islands in the North Atlantic, on a comparative scale, wouldn't have huge levels of biodiversity. Now, when it comes to our coastal areas, that's very different. Because as regards our coastal areas, they're not an island. They've always been connected to this wider ocean. And like the larger continents, it means that animals can move out when you have a big weather event, a big climatic event like an ice age, and they have the ability to return as well. So the levels of, I suppose, biodiversity that we'd have along our coastline are up there with anything that you'd see globally at this level of latitude. So it's a very different kind of level we're looking at. And this is the stuff that I'm going to show you now. Almost all of the things I show you are accessible with a pair of wellies or a pair of shoes that you don't mind getting wet. This isn't even getting into the stuff that's out beyond our depth, where you're seeing, again, levels and levels more of the stuff that we have on our coastline. So we'll have a wee look. Now that we've got a bit of context to it, we'll have a look at some of the stuff that pops up. So first of all, just to show you where you find a lot of this along the Burren. So most of you will be used to hearing about karst landscapes. You'll be familiar with this. So a karst landscape is a landscape, normally a limestone landscape, that's been shaped by water erosion. Once you get down onto our coastline, the intertidal range, so the range between low tide and high tide, we have this biokarst. And so the biokarst is a landscape that's been eroded and shaped by living organisms. Now, I don't think these organisms sat down and had a committee meeting about what they were going to do, but the result of it is what you're looking at here. And so this is effectively like a Manhattan for sea organisms. So what they've done is by eating away, they've increased the surface area of this intertidal zone. I'm not sure, I'd have to do a calculation, but you could be talking 10 times the amount of surface area. So they've increased their habitat by the manner in which they've eroded the limestone. I've also got a figure, again, this is more of a theory, but you've also got a figure that with calcium carbonate rich water being washed out from the Burren into these areas, that it makes it easier for a lot of these shell building animals to exist here, that they use up less resources in getting calcium carbonate to build their shells. Really, you'd want to talk, even for anecdotal evidence in this, you'd want to talk to fishermen. I'm sure that you'd have a difference in lobster and crab size in areas along the Burren coast as opposed to areas further south, but you'd have to find a lobster fisherman willing to tell you where big lobsters are. And that's a harder thing to find than you'd think. So we get into some of these. We start off now, again, all the stuff I'm running through here, I'm just touching on very basic bits of it. So we'll go through a few examples, but there's lots more examples of every single thing I'm going through. So the first things we'll have a look at here, just the small seaweeds. So the one on my hand there is a sea lettuce, tasty. There's another few around there, but the other one that's interesting is, I don't know if you can see it, but leading off from sort of my middle finger there, there's a strand with some small ball structures on it. That's actually sargassum weed. That's an invasive species that is from the Pacific, but is now found the entire length of the coastline. I don't remember seeing it as a child, but now from Donegal down to Kerry, it's common all over. So I think it's something we'll be living with. If you want to harvest seaweed guilt-free to use in your garden, it's a perfect species to target. Here's another one of our interesting weeds. This is velvet hornweed. Again, as with all of our weeds, all of our seaweeds are edible. None of them are poisonous. So technically they're all edible. A lot of them don't taste that great. You can eat this, but you don't get it in you don't get it in really big beds. And to be honest, haven't tried it. It's more of a texture thing. It tastes like a salty sponge. So if that's your thing, knock yourself out. Now, as far as tasty seaweeds go, this is probably the tastiest one we've got along the coast. So this is pepper dulse. And pepper dulse actually has a season that runs contrary to what you'd expect on land. So when everything is losing its leaves on the mainland here, pepper dulse is just starting to grow again on the coastline. It'll continue growing and then start to die off in spring, where it goes a sort of a yellowish color. Delicious, tastes like garlic and truffle. Don't eat a lot of it. Only eat small bits or dry it out. If you eat a fistful of this, you'll be burping garlic for the rest of the day. It tends to repeat on you. And then this is carrageen moss, traditionally used in houses as a sort of a dessert. So this is often used in vegan foods as a sort of a thickening agent or a gelling agent rather than beef extract. Tasty, as long as you mix it with sugar of some sort. Okay, so now we get into some of the squidgier invertebrates that we see in our rock pools. So this is a beetlet anemone. Now this is a particularly striking one because they normally don't come with this sort of green kind of stripes down the side. This would be a more regular looking beadlet anemone. Now they get their names from these blue beads that you see ringing the tentacles. Now the blue beads are stinging cells, but the stings they give are not. Humans, you won't feel them. Really, what these blue stinging cells are for defense against each other. So it's while you see them attached to rock, they do move quite a bit, and so they can change territory. So if another anemone gets too close to this one, he's able to hit him with the blue beads and move him off. So pretty, and they just get prettier. So this is a snake locks anemone. Not as common as the beadlet ones, but along the Burren, not an unusual thing to see. So you're looking at these on low tides. Actually, this week coming, you've got some very good low tides. So for anybody looking for these creatures, you wander down in the low tides and have a look in the pools. These guys will almost always be in pools that are exposed to sunlight. They like a bit of direct sunlight, and they don't close up like the other anemones. They stay open the entire time. You get a brown version, and you also get this kind of version, this lovely green with the purple tips. Obviously, the colorful one is a bit more picturesque. Then this guy is a dahlia anemone. Now, dahlia anemones are beautiful when they're opened up, but can be tricky to spot at times because if you move a rock they're under, they tend to do this. So they've got a number of suckers. You can just see some of them on the kind of top right-hand part of that anemone. So they've got these little suckers on the outside and they hold on to pieces of shell. And so they use this to camouflage themselves. So if you disturb them, they close in immediately and you're left looking at just one of these shell piles. So if you're not used to it, they're very easy to pass by. This is one of the bigger ones that we'll see. Again, all of these are ones within the intertidal zone. Once you go deeper than this, you've got a whole other world of anemones, but these are the ones you can see with a pair of wellies on. And so this is a strawberry anemone, named for the pattern. They get quite big. So they go from small, like the other anemones, to pretty big size, like a small saucer. Another pretty anemone. Now, into some of the more again, not unusual, just not commonly talked about or not commonly known, but on the shores here, you'll see these down in Bishop's Quarter. You get them up in areas north of Fanor. But these little blue creatures here, and they can be a variety of colors, so they're also brown here. These are star ascidians, and these are a tunicate species, colonial tunicates. So when you look at the star shape here, each one of the little arms is an individual. And these creatures are actually closer related to us than they are to anemones or some of the other squidgies we'll find, because these guys have a primitive spinal cord, really. So they're put in a branch in a family closer to us chordates. They're considered a primitive chordate. So each one of the little petals or arms of this star is an individual, and each little star is a colony. And then you've got them within this wider colony on the rock. And so these guys filter feed, and they'll feed on phytoplankton and zooplankton that's small enough. But they're also an important part of the food chain, and that a lot of other things eat them. Like my guess is that gray top shell at the top of that picture is probably munching on them. And you see they come in a huge variety of beautiful colors. Some are duller than others, but some of them are so different in color that often you've got to come back and check to make sure they are ascidians. But you get a variety of these. Now, these have actually become invasive in the US. While they're native here, they've ended up crossing the US, probably on the hulls of boats or in ballast, and they've spread along the east coast of the States. Moving into something a little more lively. So this is a velvet swimming crab. And if you're looking for lively, this is one of the livelier crabs we have. These have been known as one of the more aggressive species. If you turn over a rock, these guys, they'll come at you. They get quite angry at being disturbed, and they're fast. But they've got a velvet fur on top of them. That's where they get their name. And like all swimming crab species we have here, their back legs tend to be flattened. They're harvested in this country commercially, but they're not eaten in this country. So most of this would all be sent to Spain for a Christmas market. Very tasty, but again, not commonly eaten in this country. This is tricky. This is either a harbor crab or a flying crab. it's difficult to tell the difference at times. But again, they're another species of swimming crab. You can see the flat back legs here. And so they can move halfway up the water column, back down again. They'll often bury themselves in sand, but they have the ability to move to the surface of the water and back down again. And we have, in the Hinch Bay alone, I think I've 4 or 5, at least 5 different species of swimming crab in Lynch Bay alone. This is a juvenile shore crab, which would be one of the more common ones you tend to see. Normally the adults are green looking, but the young can have a lot of different patterns like this. Now they're invasive in the States again, and they're actually looking to develop a fisheries over there. So they're trying to find ways to eat them. What they're really looking for here is they're trying to find indications of when they shed so that they can open up a soft shell market for them, as they think that if they can get them when they're soft during one of their, after they shed their shells as they grow, for the first day or so, they're very soft. And there's a big market in soft shell crab in most countries. And so they're trying to see if they can do this with the green crab. Something we'd watch with interest here, because if they manage to do it over there, it means it's something that we could probably do here. Now, this is a furrowed crab. I should point out the crabs that we've seen up until the furrowed crab are considered true crabs. Furrowed crabs are not. These guys are potentially poisonous if you eat them, so probably better to stay away from eating them, but you can handle them okay. Now, when I say true crab and non-true crab, for zoologists, they've discovered that a lot of kind of arthropods, creatures with hard or jointed bodies, it seems that given enough time, a lot of different species tend to evolve into crab-like shapes. They call it carcinification. And this has happened so often in the past in the fossil record that it's often joked about that if you leave any arthropod alone long enough, it'll eventually turn into a crab. And so we've got these furrowed crabs, which are one of the most common crabs we see under the rocks along the shore here. And they're not always purple, but they do come in some nice colors. And then here's a broad-clawed porcelain crab again. Again, not a true crab. So this yet again comes from a different species of arthropod that has evolved into this crab-like shape. So it seems that that crab shape is a very useful shape, and that quite a number of different species or different branches of animals have evolved into crab shapes independently. There's our European lobster. That's the one we tend to think of along here. We've also got a crayfish species that turns up, it doesn't have claws. It's a spiny lobster that turns up when the water gets warmer here. So really it's only a seasonal visitor, whereas this species is here all year round. This one here's good. The claws on this one are a little yellower than your regular one, but there's quite an amount of color variation. Then we get down to the smaller ones. So these are your squat lobsters. Again, under the rocks here. This is an olive squat lobster. And then this one is the prettiest squat lobster I've ever found. So this one doesn't have a common name, but the markings are just beautiful. It's got these red joints and very small. I mean, that's about the size of your thumbnail. And it's sitting on a mat of bryozoans. So these are another little filter feeder that form mats. They grow on seaweed, they grow on rocks. They often turn up in the fossil record because they preserve well. But I almost took this wee fella home. Here was that taken by him. I hung out with him for about 10 minutes, then released him again, but he was very, very pretty. Okay, so this is that process of shore crabs molting. So they molt as they grow throughout their lives. And this is a female extracting herself from a shell. It's unusual to come across it, even though this is something that happens regularly. They normally hide when they're doing this because when they come out, their bodies are soft and they're very vulnerable. So it's unusual to catch them at this. Often too, males will hold on to a female when she's in this process because that is the time they can mate, when the female is soft-bodied. So often they'll be protecting them. So you can see she's just popped out. She's trying to right herself, but she's very rubbery. She looks like a crab, but her legs are like elastic bands at this stage, and they will be for a few days. You see she gets turned over. She's still got a scar on her head from a previous injury. That's gone into her second molt here, but yeah, she's rated round. Then we have our common prawns, which you find rock pools all along the coast here, and seaweeds and estuaries. Very tasty, even though we don't really have a tradition of eating them. These are very tasty. You'll get them in almost all the harbors we have around here. If you have a harbor with a freshwater river near it, you should have these, and especially August, September, late into the year. It's a good time for them. Often they're harvested. The most common time you'll see them harvested is to be used as bait for salmon fishing, but it's a waste. I mean, they're tastier than salmon on their own. And these are kind of invisible as well. They use camouflage and also the fact that they're see-through. We're having a good look at each other in this one. Okay, then on to some of the other ones, some of the sea slugs. Again, this is something you don't tend to see. It's something you're not told about much growing up here, or even growing up on the coast myself. I suppose when they don't have commercial value, often people don't talk about them much. But tealing, keeping an eye out. But often they're quite common along the coast, and they're beautiful. These guys can be a different color depending on the seaweed they eat. And if you poke them or touch them, they can eject like a dark purple dye. So it's not dangerous to humans, but it's obviously a deterrent to predators. And they're part of these families of sort of nudibranchs or sea snails. So this is a yellow plumed sea slug, and there's another species of nudibranch underneath. Now the nudibranch species, when it comes to names, I'm not very good on these because they don't have common names. So it's all Latin names, and identifying them can be a bit tricky. So I'm not, it's tealing again. So I'm not as, I'll just call them by colors. So this is a beautiful red one that we got. Again, these are on the coast of the Burren and down under the Cliffs of Moher. This one again is about the size of the last digit in your little finger. And so they feed on seaweed, and again, they take on their colors accordingly. They tend to be colored very brightly because obviously they're toxic to other animals, but really spectacular. The only reason that you don't see them in aquariums, I mean, these are a desirable thing for aquariums, but the reason you don't see them in is they're very difficult to keep alive because each species specializes in eating on another type of animal. And if you haven't identified that, then it's impossible to keep them alive. So I suppose the lack of knowledge in that is a good thing, in that they're not harvested like that, but surprisingly common. Once you start to realize where they are or what you're looking at, they're not that hard to find. Whereas I would have gone years and thought I'd never seen them. And then once I turned over a rock and realized what I was looking at, then I realized I'd been looking at them for quite a long time. You get excited then. So here's a little video of it just moving. Beautiful creature. So these papillae, they're hair-like structures on their back. Again, depending on what they eat, the colors of the substance they eat end up filling up these papillae. And also, if they're eating something that has a toxic element to it, the toxin can become concentrated in the papillae at the ends. And this is obviously a form of defense for them. This little hairy looking one here. No idea what it's called. Another one with a little blue touch to it. Again, I've gone on the websites to try and check these out. There are hundreds of different species. It becomes very difficult. Well, there's some very good Facebook pages with a few nudibranch experts. I can see how people will get lost in these species in particular. And it seems that you get people that just dedicate themselves to chasing these down and to photographing them. But they're totally understandable. And this one is called a grey sea slug, which is a disgrace of a name for such a lovely looking creature. So one of the kids I'd shown this to recently said it looked like dragon scales. I think it's a much nicer name for it. Then we get on, oh, that was a chuff in the background there. So then we get on to the grosser looking ones. So this is a sea cucumber. You get them on low tide. So this week it's possible to see some of these sea cucumbers. But in general, they're not something that we tend to, fishermen would be common or familiar with them, but they're not landed because we don't eat them in this country. There's a large market for them in China, so they tend to dry them out in Australia and sell them on. I've tried eating them. Had them at a restaurant once, with crab meat, I can only describe it as if it's as if somebody put some crab meat on a plate and then sneezed over the top of it. It was like a clear mucus. So obviously the texture is the draw because it doesn't really have much of a flavor, but it's quite popular. And I'd say the problem with them in this country is we don't have the climate to sun dry them. So it's never really been a market issue. They also have a pretty disgusting habit of, if you bother them, so that one you could see was really loose and limp. If you touch them, they harden up and they eject their own guts out of their mouth as a defense mechanism. Yeah, tends to work. You see that happen, you tend to leave them alone. And we've got a couple of the weirder worms here. So this is a peanut worm. Cannot really tell you much more about peanut worms, to be honest, just that they're one of the oddities. And this terabellid worm, which looks like some sort of alien. Not something I find regularly, and not too many records of them along the coast here, but they're clearly there. Okay, so this is our purple sea urchin. The purple sea urchin is lovely, but it's kind of sad about these along the coast. There's a few other animals hidden there, but the sea urchin, the story of sea urchins here is kind of sad because up until 1973, a coastline was covered in them. You would have had difficulty swimming in the Burren or off Burren shores the whole way up to Galway without stepping on these because they were everywhere. And we know they were everywhere because people tell us they were everywhere, but also because of these, we find rocks like this all over the Burren shoreline. And these are empty sea urchin sockets. So sea urchins are able to make these holes in limestone and sit in them. And so occasionally you'll still find a pool. And if you do find pools of these, you're probably better to keep the location to yourself. Because what happened was in the 70s, it emerged that the Irish discovered that the French were eating these and were willing to pay pretty good money for them. And so a fishery developed very quickly. Now, I'd assumed this fishery lasted for about 10 years, which is sort of the cycle of a lot of our boom and bust fisheries along the west. But I was talking to a local who was involved in the fishery here a couple of years ago. He told me that the fishery lasted for 3 months, that over one summer they cleaned the entire Clare coastline of these. He said that for that summer in 1973, you could make more money on your feet on the shore than you could if you owned a boat and were going to sea, because they were shipping them in these wooden boxes and everybody was down gathering them. Now, some people with scuba gear would have made a living for probably the 5-10 years afterwards, reaching beds of them that were beyond the tidal range. But the whole tidal area that we know was cleaned out in a 3-month period. Now, they thought, the locals themselves assumed that they were going to come back, that these would regrow. They never have. So this would have been a huge change to the coastal ecosystem here. You'd removed a huge amount of seaweed grazers, and obviously that would have affected, had a spill-on effect for the rest. So then we get your painted top shell. Just going through some of the pretties here. This is a little Arctic cowrie. Again, this is about the size of the end of your finger. And this is a little predator sea snail. And here's one of them that I've uncovered. And I don't know if you can see there, but what he's doing is he's eating a mat of staricidians. So you can just see in front of him, you've got these staricidians, and he's one of the creatures that likes to munch on these. Then we've got a female pipefish. Lovely markings on her. You can see her little head there. So these are related to seahorses. And so you can see that in their head, very similar shape. And just like seahorses, so this is a male, just like seahorses, the males get pregnant. So they'll meet up. The eggs will be fertilized, and then the male will carry them around and care for them afterwards. If you turn over rocks and you find these, just be sure to put them back onto the rock you found them, because they're very territorial. And if you move them outside of the territory, they often don't fare well. This is a shore clingfish. Common as well down here and along the Burren. We've even got our own species of these that doesn't have the blue dots, called a Connemara clingfish. They're very unusual down here. These are the ones you tend to see most. And they look sort of like a flattened fish. The first time I found one, I thought one had been run over, and I couldn't understand how I wasn't able to pick it up. It was baffling to me. And then I found out it was because of this. So they've got a modified kind of pelvic and pectoral fins. They're modified to form a sucker, and they use this to cling onto rocks in the intertidal zone. So it means that when waves crash over, they can hold their place. They'll also suck onto your hand. They don't cause any damage. But they're one of the more unusual kind of built little creatures we'll see. Sand eels or sand lancets. They spend a lot of the time buried in the sand in our beaches here. And this time of year, they're swimming around, and they're one of the one of the very important foods for a lot of our bigger marine creatures. This pretty little fella is a scorpion fish. So he looks pretty drastic and even dangerous. He's got these two spikes above his head there. Not poisonous at all. A lot more dangerous than he looks. He's related to the rockfish or stonefish in Australia and to the lionfish. So both very toxic species, but this one is not. This one is not. They're very common along our shoreline and called cruggerlines up in Donegal. This would be a male cuckoo wrasse. Yeah, one of the people don't tend to think of Irish waters as tropical, but we have more than enough fish with colours that would lead you to believe otherwise. So this is a male cuckoo wrasse. Now, all cuckoo wrasses are born female, and the females are an orange colour. What happens is if the male in a group dies, then the next biggest female changes sex and colour to become a male. If another large male reappears, he can actually change back into a female again. And so sometimes you'll catch them midway through these transitions, and then their colors are even crazier. So you'll catch them midway through a change to a male or a reverse to a female. So very interesting fish and stunningly colored. This is a pouting, looking unimpressed at being handled. Triggerfish off our coasts in the summers, and if they don't get out in the winter, they will die. Because when the water gets colder, they die. Now, this video, I'm just demonstrating why they're called triggerfish. So I'll just play that again for you. And that's because they've got this large dorsal spine. And if you pull the spine up, it locks in place, okay? And can't be pushed back down. The only way you can get it back down is to pull the smaller trigger spine behind it, and then it'll fold down. This is another defense mechanism. They can get into small crevices if they feel threatened, and they're able to raise that spine and lock themselves in place so they can't be pulled out by predators. Works most of the time, but I have found one that's managed to wedge himself in a traffic cone and had to get him cut out. So good for everything but plastic. This is a boarfish, another common species off our shores. Occasionally they wash in dead. They're commercially fished for a while there. It wasn't a great idea. Now this is something we find all along the coastline. So this is evidence of some of the bigger animals that we have out there. And this in particular are shark species. So I'm aware I've got a few minutes here. I'll try and run through some of this stuff. So these are shark species. These are commonly known as mermaid's purses. This one is one of our smaller species, our lesser spotted dogfish, and you can see the embryo inside there. But often you're finding them like this washed up. So this is from a bullhuss, which is a bigger species of shark. Skate species. Then we get into this bigger one. So this is a white skate. There's only 2 known breeding sites for white skate in the whole of Europe. So when we find these washed up on our coast, this is evidence that these endangered animals are breeding off our coast. And this is very important. So they think that down off Kerry, there's a bay down there, they're breeding. It's possible this is washed the way up from Kerry, but it's also possible that we have a breeding site off the coast of Clare that we haven't identified yet. But finding these fresh like this is fantastic evidence of the life that's just out past the shores. This is a flapper skate egg case. And so this is an egg case from the largest species of skate in the world, okay? Only about 15 years ago, they've actually identified this. We used to think that the blue skate and the flapper skate were one species. But if you see their egg cases, it's clear they're not. And it was through DNA, they worked out they weren't. So the flapper skate is actually the largest species. And I'll find maybe half a dozen of these washed up between the Cliffs and Moher every year. So we've definitely got a population of these breeding out. They were heavily targeted back in the 80s and 90s, and their numbers dropped away. but now they're not really a target species. So it's nice to see that they're breeding out there. Basking sharks, everybody gets excited in April and May when they turn up off the coast here. Again, these are a good, it's lovely to see these back, because I suppose the famous fishery was up in Achill. So in Achill, they had a fishery that at its peak was catching hundreds and hundreds of these a year. And that fishery crashed. And we have very good records of that. So it's a famous fishery in marine biology circles, because you're able to see the takeoff of this fishery, the numbers grow, and then the crash. And that's what happens when you target a slow breeding species like these. Now, the Achill fishery probably wasn't the reason that they were crashing that hard. The salmon drift net fishery and some of our other gill netting fisheries were a large contributor. You'd have had many of these being killed every year, but not landed or not reported. Once the gill netting and the drift netting was banned over 11 years ago, we're now starting to see groups of 50 or 60 of these turn up again. And these are bigger numbers than I remember seeing in my lifetime. So it's lovely to see some of our bigger animals possibly making a bit of a recovery here. Whale shark vertebrae that I found down near the scanner. They look distinctive, but the smell is a real distinctive thing. So any of these large sharks, the majority of them don't process urea the way we do. So they end up with a buildup of uric acid in their flesh. So if you come across any old bits of shark, it stinks of piss. It's quite distinctive. So these are whale bones. This is so this is a sperm whale, apart from the neck. We get them off the coast here. We have over 36, 37 different species of dolphin whale that we see off the coast here. Again, the bodies will wash up, but more interestingly for us, this is washed up along the shore. So this is a bit of ambergris that I found. So 5% of male sperm whales produce a waxy substance in their intestine. They either poop it out or it grows so big that it blocks off their intestine and kills them. And then when they decompose, this floats up. If it's spent a lot of time in the ocean and it washes in, it is worth quite a bit of money. So this piece was about half the size of a tennis ball, and this paid for my tax and insurance for the van for the year. So the perfume industry uses it, and the longer it's been at sea, the more valuable it is. So this stuff is floating around out there, so it's always worth keeping a wee eye out. And if you do find any large clumps of poopy smelling material, give me a call. Just a quick flick through some of the bird life there. So choughs, although not a marine creature, to be honest, they exist so close to the coast, they may as well be. Anybody who lives on the coast, right on it, will be familiar with these. And you only get them on the west and south. So our fulmars, guillemots, kittiwake chick, and puffins. So again, these are all marine creatures that operate. They don't normally breed along the Burren, but they definitely fish and feed up along there. And a quick run through some of the stuff that doesn't grow here, but drifts in. And so these are goose barnacles or gooseneck barnacles, and they grow in floating debris. When you get them this size and they've washed in, it normally means they've crossed the Atlantic. They've been at sea for months, and they've come from much warmer areas the whole way up here. So these are open ocean travelers. And we know they cross the ocean because you sometimes get them growing on debris that has clearly crossed the ocean, like this American football found down in Doon. These are boy barnacles, another species that similar, but they grow their own floats. And then this is a Columbus crab that I found on a log that had floated over. So this is named after Christopher Columbus, who found one on the way over and thought it was a sign of that he was close to land. So he described it and kept it in his cabin. So they ended up being named after him, but he was wrong. These guys actually, their larvae are free floating. And so they attach themselves to floating material while out in the ocean, and then they grow. They can't survive here. So this guy kept him alive in the house for about 3 or 4 days, but he eventually passed away. But it's the first one I've ever seen. A few have washed up recently. And we have our salps, little filter feeders from open ocean as well that wash up occasionally. This salp has been attacked by another alien-like creature. So this is a phronema, or a pram shrimp. He's got no pigment because he lives in deep ocean, so he doesn't need it. And this guy likes to find barrel salps, eat the insides out, and then lays eggs inside, like the eggs you can see here. They then push this around, and that's how they get the name pram shrimp, because they've seen pushing their babies around in a salp body. And their eyes, when it looks like he's looking at us, he's not. His eyes actually face up the way. So if you look at this one, you can see the facets in the lens at the top of what looks like his brain. They're actually his eyes. So he's got like telescopic eyes that face up the way because he's looking towards the light. So his eyes are designed to take in any available sunlight. By the wind sailors, we've been getting thousands of these washed in the last few weeks. Portuguese men of war, again, these have been washing in also. Part of the reason for that is we had that large storm in June, and I believe that it shoved a lot of creatures from further south in the Atlantic up into the north. And then over the last 3-4 weeks, those things have been drifting in on us. But I think that they were pushed up in June because we're seeing a lot of warmer water, open ocean creatures being shoved up, like these. Now, I had never seen, I knew these were out there, but until this year, I hadn't found them. So these are violet sea snails. And these guys are interesting because all sea creatures, well, almost all that work around the surface, like seagulls and dolphins and sharks, have a dark coloring on top and a light coloring underneath. So you think of mackerel, almost any fish you can think of has a lighter bottom and a darker back. And that means that they're camouflaged when you look at them from above, and also camouflaged looking up from below. These guys are the opposite because they're upside down in the water. Okay. As far as these snails are concerned, all of us live upside down. For them, under the water, against the surface, that is their surface. So they feel that they're moving along the planet, moving along the undersurface of the water with the sky beneath them and ocean depths above them. So they live in what we consider to be an inverted world. But as far as they're concerned, we're all upside down. And then lastly, just a couple of the plants that wash in here. So while these aren't considered part of our biodiversity yet, temperatures keep going up, they could well be. So this is a seed from a large pod plant in the Central America and the Caribbean, and this is a coconut. Now, both of these things have washed up on our shore at times and are often still viable. Like these seeds you can plant in your house, they will grow. The problem is they'll get to the height of your ceiling in about 2 months, and then you put them outside where they die in the cold, or you need to get a 30-meter greenhouse for them to grow. But a lot of this stuff drifts the whole way across the ocean and is still viable here. So some things that we have here, that's probably how they arrived back in Ireland, but we've still got stuff trying to get there. Now, one last point just before I go, all of this stuff. So I've been turning over rocks since I was about 4. I took a 10-year break where I left the country and went away, and then I came back. So about 30 years of flipping over rocks and walking around seashores. There's not a single week, definitely not a 2-week period that goes by where I don't turn something over and I see something I've never seen before, and I've got to go home and spend the day looking at it. Guaranteed every week to 2 weeks. And that's looking at it for 30 years and studying it. So there's stuff, it's unknown the amount of stuff that's out there. All right. If you have any questions about those pictures, fire away.
Thank you, Cormac. It was almost felt like it was a different world that you took us into. Unbelievable that you've been looking at these for 30 years and still finding something new. I guess that's a big motivation for you to keep doing it.
Well, there's so much stuff in it. Like it's such a different, well, studying zoology and that, you get a bit of envy when you're a kid in Ireland. You start to look at other countries and you're like, oh my God, they've got orangutans and they've got, tigers, everything. And you think that you're hard done by. But it wasn't until really I went away and I started realizing, because I grew up on commercial fishing boats and that, I'd seen aliens coming over the side. Like we had a freezer full of stuff at home that was unidentified. We had to get people to come around and try and name stuff for us. And that was as a kid. And so as an adult, I kind of realized, I was like, oh, we have all this here. And then when I just started looking on the shores, you realize you don't even have to be out trawling up the depths to find that. There's loads of stuff on our shores, loads of stuff.
I'm going to
Cormac,
just
may-
ask you one, sorry, John, I'm just going to ask you a related question and then hand over to John. And meanwhile, of course, anyone in the attendees, if you have a question, put it in the chat. What are your top tips, Cormac, if you're going out on the coast? Because there's a difference between noticing things and you know, you could be walking past amazing stuff. Is there any few things you tell people to follow?
Top tips for it: check tide times. So you're looking for low tides. Your tide cycles tend to be that you'll have at least 1 week in the month where you've got really good low tides, and there's a number of different sites you can look up for that, but you'll at least have 1 week in the month. 2 weeks really, but at least one where it's good. You can get down there because on the really edge of the low tide, when you get that 1 week where it goes really low, that's when you get a chance to see stuff that is kind of got caught by surprise. There are animals that are kind of expecting to be covered and have all of a sudden been uncovered for the day. So that's when you really get to see stuff on the edge. But to be honest, you don't need a super low tide. You go down there, you're going to see crabs, anemones, you'll be there a long time before you run out of things to see, even on a regular tide. But keeping an eye out in tides is the big one. That's the biggest thing. You're looking for also, if you have a bay, you'll often have one side of it will be kind of rocky and the other won't. The rocky sheltered side, that's the one where you'll find most stuff. You'll find more creatures in that rocky sheltered side. So an example, again, I'm taking the outside of the burn a little, but an example would be, say, White Strand, right? White Strand's a nice small little beach. The left-hand side of White Strand, when the tide is out, if you want to find aliens, go have a look there. Yeah.
Very good. John, you were saying something.
Yeah, I was about to ask, first of all, Cormac, the photographs are amazing, and the movies, they're just amazing.
Yeah.
But may I ask, are they all from the Burren coast or close by?
Oh, all of that stuff is either the Burren or just slightly to the north, like just beside it. Now, everything I've seen, everything I put there, some of the photographs may be from, say, kind of the scanner, but all of those things I found up on the Burren as well, like all of them. So I haven't really hit on stuff around the scanner that you don't find in the Burren, you know. In fact, if anything, I'd say you probably have more of a variety up there around the Burren. Like if you go down to Bishop's Quarter on a very good low tide, it's crazy stuff. Sea gherkins and all sorts of nutty stuff. Like, yeah.
Cormac, Jenny McGuire says, wow, thanks for the incredible photos, fascinating stuff. And a question, no mention at all of jellyfish. Are we seeing more than usual amounts than normal? And is that related to temperature changes?
Yeah, no mention of jellyfish, just there's so many things I didn't mention. Like I said, these things I touched on, they're tiny. Like the crabs, that I could have spent 40 minutes just talking about the crabs you find in this area. In fact, any one of those areas you could have picked. There's just so much of that stuff around here. Jellyfish, there's with the way the winds have been lately, we've got loads of jellyfish washed in. So there's lots of, what I'm seeing at the minute are moon jellies and compass jellies. They're not unusual species for here. It's just the jellyfish, often winds dictate where they go. And so if you get winds that's unsuitable for them, you can end up with a bay just packed with jellyfish, which is what's happening at the minute. Yeah.
And Cormac, you've been watching this coastline, you know, regularly over the last 10, 15 years. What are the big changes you've seen?
Yeah, that's very difficult to tell. As you can tell, I'm still discovering stuff. So it's very hard to say you're getting changes when I still don't really know what's out there. Like what tends to happen is you discover something that you haven't seen before. And then all of a sudden what you've really done is you've found out how to find them. And so you then are able to find them much more easily because you've kind of got your eye in. And so then you're going, well, I don't know. Really, you have to be studying one or two species in particular exclusively to see if there's a change or not. I'm spread a bit too thin, I think, to be able to really, there's so much different. Now, what is happening on this coastline is that County Clare is the flattest coastal county we have. So we're having like really quite large amounts of erosion here. Like from being at the Cliffs of Moher for working there, you get to see huge bits of it fall off. But I remember in 2014, going to a farmer south of here, after one of those big storms, we had the battered Lynch, and he lost 60 foot off one of his fields in a single night. So you probably, because this is the flattest coastal county, my guess is that the erosion level, and it's on the west. Your erosion levels here are probably higher than any other coastal county. So you're losing land is what you're losing.
Yes.
Do the particularly say at Fenor now, where there are efforts to rejuvenate or protect the dunes, are those measures effective?
Well, they're effective for the dunes themselves and that they're habitat themselves, but from some of the larger, like the events that have caused the biggest erosion, the biggest jumps of erosion have been those big winter storms. And when you get one of those in, like, I mean, any amount of planting in the dune is going to slow down how much gets eaten, but when you get those big storms, like they're going to struggle very. Like Fenor's one, but Doonbeg is somewhere that they're going to have to watch very closely. Doonbeg, if they don't get some sea protection, they're about 1 or 2 big storms away from that Gulf course being washed away. Yeah, it's a crazy thing. I look at that and I think, like, if they weren't going to build it, they shouldn't have built it. But seeing as they built it, to watch it wash straight into the ocean seems a crazy thing to do, So
the other thing, of course, with the storms, then, are we seeing more and more creatures? As you say, you're finding new creatures or new, interesting things almost every time you visit a shore.
Well, when you get those storms, especially those summer storms, like that was a late storm. To have a storm in June, like the one we had, that's a
Crazy, yeah.
And so that would have shoved a lot of animals that weren't expecting it up into the Atlantic. And so we get them drifting in now over the summer. Whereas normally the winters when you expect to start seeing those things, or entirely spring after your winter storms where the Atlantic has been kind of churned, then we start to see that stuff drift in. To see the amount of it coming in summer now, like, again, it's hard to know if that's a difference. Like, how long has that pattern been going on? Because, like, triggerfish, for example, you get people telling you, because triggerfish die off in the winter, right? So people say the emergence of triggerfish is a sign of the temperature going up in the waters. Now, the temperature is going up, but triggerfish have been appearing up off Donegal, like, way back. Because I remember somebody writing a paper about this when I was 11 or 12. And he'd put a thing in the skipper of the fishing news asking for triggerfish, and I pulled the one I had out of the freezer and measured it for him. But I'd gone down to a neighbor's house, fishermen. They were able to tell me about catching triggerfish 20 and 30 years prior to that. They were aware of this species. They didn't use it commercially, but they were aware it had come in some of they caught them in fishing pots and they'd remembered them. So you're going, although people may have stuck their heads in and started scuba diving and the last 20, 30 years and seeing these things and saying they're new, sometimes you find that these things, they've had a longer standing presence here. So I'm wary of attributing things to that. There are, like, we definitely have changes that are happening here because of a temperature change, but I'm wary of attributing anything you sort of find as new to it. Sometimes I think it's just we haven't been looking at it.
Of course, yeah.
Very good. I think we're running out of time, Cormac. Just if people want to get in touch with you or do a walk with you, you have a website, don't you?
I have a website, and also, look, if they're into that kind of stuff, if they're into this coastal stuff, I have Cormac's Coast on Instagram, on Twitter, and on Facebook, and basically that's all I post. I just post pictures of the dog occasionally, pictures of scenery and sea life. Pretty much that's it. So if they're into that, they can just follow that.
Fascinating. Yeah. Thank you so much, Cormac. That was brilliant. And I'm glad I recorded it so it'll be on our YouTube channel for all those people who couldn't attend today. And, it's a fantastic resource to have to go back to in case we find one of those amazing, fascinating creatures. So thanks again, Cormac. Hopefully we'll have you out on a live walk soon for Burren. So good night, everyone. And we'll see you at this time in next month in August, where our webinar is on the wetlands in the Burren and Turloughs with Micheline Shees Keppington. So thank you again and have a very good night. Bye.
Goodbye, folks.
Bye. Thanks,
Bye.
Cormac.